Hi everyone. Today we are gonna challenge ourselves with the Leetcode 33, search in rotated sorted array. Let's read the distribution first. Suppose an array sorted in ascending order is rotated at some pivot unknown to you beforehand. So here's an example. If an array is 1, 0, 1, 2, 4, 5, 6, 7, then that may be at number 4 point that it got pivot. So it's like 4, 5, 6, 7, 0, 1, 2. So actually after 7 and before 1, there is a changing point. And then you're given a target value to search. If found in the array, then return its index. Otherwise, then return -1. You may assume no duplicate exists in the array, and your algorithm's runtime complexity must be in the order of log n. So based on this information, we can infer that actually this Leetcode challenge wants us to solve it with binary search. If you still remember binary search, it is a simple way, like if we had an array, let's write 1, 2, 3, 4. Sorry, my handwriting is a little bit ugly. And then we find the middle one, for example, here. And then because it's sorted array, so if our target is 3, then if the middle one is less than 3, then we move the middle one to here and keep finding. So this binary search will only allow us to search half of the elements in the array, which means it's a log n search. But here we have some trouble because the whole array is not generally sorted from the lowest to the highest. It has a rotate in the middle. So if this is a linear distribution line, it's like 0, 1, 3, 4. If we write it in axis, then a rotate one will be like this one, right? So for example, if we paint it in axis, it will be like this. Ascending, then suddenly be interrupted, then ascending again. But the first one and the last one will not be inversed. So based on this map, we can imagine if our middle point is here, then we can simplify the target either in the left arm or in the right arm. And this is the first case. So for example, if our middle is larger than the left point, here is the left point, and here is middle. Then we have two situations. Either the target is here, or the target will be in the right arm. So if here it is L less than target less than middle, and else it will be the other way around in the right arm. And then the second case is like the middle is here. So it's like middle less than right. Then we all have the same case. If middle less than target less than R, then it will be in the right arm. Otherwise, the target will follow into the left arm. So here it's 2Ks as well. And now we can go back to write our code. So let's see. Okay, I will change it back to... I prefer a dark mode to write code because then will protect your eyes. If you spend lots of time in front of the computer, your eyes will get tired very easily. So I would suggest you can add a dark mode. So here, if we write our mid search, and it will only has a list as an argument. And then if the length of list equals 0 or not less, then we return -1. This one is some edge case, like the list not even exist. And then we get right, left and right equals 0 to length less -1. This is the one to point at left point and right pointer, while L plus 1. Here is an interesting way to deal with the binary search, like we put L plus 1 minus R to avoid the duplication of the point middle on the left point and on the right point. So after it finish, we will be like if target, oh sorry, we need to import the target as well. If target equals less L, then we return L. If target equals less R, we return R. Otherwise, we just return -1. This is not front case. And then in the loop, we will implement into 2. One is when the middle point minus left point, it will be the first case. So if less mid left, and within this case, it will be left less than and equals to target, and target less than and equals to middle. So it's if less L less than equals to target, and target less than and equals to mid, then it will definitely in the left arm, and then we just move the right to minus middle. Then right equals middle times 1, else it will be to the right arm, then it will be move the left pointer. And then the other case is when our middle less than R, then it will be in the second case, right? In the whole right arm. So it's like less middle. Oh, sorry. I forgot to put middle equals to left plus right minus left times 2. And here we need an integer. Why to write it like here? Because if we simply do it like right plus left divided by 2, then if the right index is super large, then those plus might cause some overflow of the integer type, then it will return you error number other than then the middle won't be correct. So if we use the minus operation, then that will avoid this problem. So this one is lefter than right. Right? In the third case, the middle term less than r. And then our case should be middle smaller and equals to target, and target smaller and equals to right. So middle smaller and equals to target, and the target smaller and equals to right. And then it will be on the right arm. Right? If it's here, then it's in the right arm. Then we move the left one to this part. So it will be left equals middle plus 1. Otherwise, then we move the right arm equals middle minus 1. And then we put another one. If less middle equals to target. So this edge case is like if target equals to left or right. And here, if target equals to middle, then we return middle. Oh, 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 oh. So this is a function. Other than the function, we return mid search nums and target. Okay, correct.